Hi everyone, and I warmly welcome everyone on the Ethereum smart contract hacking presentation. My name is Zoltan Balazs, and I'm mostly into offensive tools. I did develop some offensive tools in the past, like the zombie browser toolkit, the hardware firewall bypass toolkit, malware analysis sandbox tester tool. I played with some crappy IoT devices. And one of my exploit codes ended up in a botnet. I didn't want to do that, but that's what happens with offensive tools. And last but not least, I'm also responsible for creating the Diffie-Hellman key exchange-based encrypted exploit delivery, which was again exploited by the bad guys. But today we are going to talk about Ethereum. Hands up if you know something about blockchain, you heard about blockchain. Okay, that's good, almost everyone, so that's cool. Hands up if you have ever tried to explain Bitcoin to your parents, kids, colleagues, whatever. Okay, basically the same number of people. Hands up if it's complicated at the end of the day. Right? Cool. And hands up if you have ever interacted with a smart contract. Okay, that's pretty cool, like 10 people. Very good, very good. All right, so first of all, why am I talking about this topic here? I believe a lot of people, especially from the ITsec community, they laugh a lot about blockchain. And the ITsec community believes that it is not happening, it is not important, it is not working, it is not scalable. I don't care about this. Unfortunately, business doesn't rely on our opinion, or maybe fortunately, I don't know. We will see this later, but it is actually really happening. And business people put a lot of money into blockchain technologies and into smart contracts. So I believe this is a very, very important topic, and it will be important in the future as well. I will talk about a lot about money, but whenever someone tells me that some company lost 300 million US dollars, I have no idea how much money that is, right? That's a lot. I know that's a lot, but I have no idea. So I was trying to figure out how to best explain to everyone how much money we are talking about. And I realized that in the blockchain world, there is one constant convertible everyone is using, which is the Lambo, right? So if you are in blockchain, you want to buy a Lambo, right? So we will calculate everything in Lamborghinis. And last but not least, who am I to talk about this topic? According to the largest professional network on the world, I'm a blockchain expert. Yay! But I'm not giving you any advice on selling, hodling, or investing, or anything in the blockchain world. How many of you guys know what hodl is? Okay, if you don't know that, Google it. I think it's a very awesome story. So, but let's start with cryptocurrencies, right? And I promise you that I'm going to explain to you blockchain and cryptocurrencies and smart contracts in an easy way. So let's go with the metaphors here. I believe math is hard. At least it is hard for me. So let's say we are solving some kind of mathematical challenges, and we call solving these challenges mining, right? And what's pretty cool in this mining is that it is very easy to check whether someone solved the challenge correctly, but it is hard to solve the challenge itself. But you can check whether the solution is correct or not. And whenever someone is the first who solved the math challenge, he will get some monies. In my presentation, monies is my imaginary cryptocurrency, right? Now let's talk about transactions. So for example, there is Bunny and Piggy, and they are doing these mathematical challenges. And Bunny has already some monies, and she wants it to send to Piggy. What's interesting in the blockchain world is that this transaction is public, and everyone will know that someone sent this amount of money to this other someone, and we know the amount, date of time, these kind of things. Because it's public knowledge, right? This is how blockchain works. Ethereum is a little bit different, but I don't want to go into real details here. So, but what is blockchain? Blockchain is that whenever there are many transactions which are collected together, we basically, which are not yet processed by the whole peer-to-peer network, we bundle these transactions together, and we add these transactions as part of the math challenge, right? So whenever there is a new math challenge, all the pending transactions are part of it. So the solution depends on these pending transactions. And also because you want to basically transfer money from one party to another, there should be a transaction fee, because otherwise, if you can do a transaction for free, the network will just collapse. It doesn't make any sense. And now we have a very long, basically, paper trail of every transactions and every math challenges and every solutions to these math challenges, which are basically chained together. And this is how we call what we call a blockchain, right? Easy peasy. Now, if you are a newcomer to the blockchain world, how can you get some monies, or for example, Bitcoin? First of all, you can start solving the math challenges, right? You can buy hardware or whatever you want to do the mining with, and you start mining. But before you can do that, usually you have to receive the long copy of the whole paper trail, and you have to be synced with the network in order to start solving the challenges. Also, if you do the challenges, it is not just that you receive the monies for solving the challenges, but also if you include the transactions in these challenges, then you get the transaction fees. Or, last but not least, you can ask someone else, please send me some monies, right? And you can do this in exchange for anything. At the beginning of the Bitcoin world, for example, there was this guy who was running an alpaca socks shop, and he was selling alpaca socks for Bitcoin. And because it was the very few shops where you could buy with Bitcoin, it was very popular with people. So a lot of people from the Bitcoin world had alpaca socks. Cool. Now let's talk about wallet. What is a wallet? The wallet is basically what holds all your monies which you have previously received. Yeah, like same with the physical world. And whenever you send money from your wallet to someone else's wallet, you basically sign the transaction with your signature. And because this is based on cryptography, it is impossible to counterfeit this transaction. Which means transactions are irreversible and final, which is good most of the time. And because it's in the public blockchain, everyone will know that you transfer the money, you cannot draw it back. But why is this really interesting? What makes this whole blockchain idea really interesting is that you don't have to be in the same room to do these math challenges, right? You can do all this stuff through the internet. That makes it really distributed and peer-to-peer. And at the end of the day, you don't even have to know who the others are. I mean, most of you guys know that blockchain itself, or for example, Bitcoin itself, doesn't provide good anonymity, but it provides some anonymity. And I think at this stage, you already know a lot more about blockchain technologies and cryptocurrencies than the generic managers at startups who are creating blockchain technologies, like at Dilbert's. How many of you guys like Dilbert? Okay, good. Awesome. So, I think the best definition of cryptocurrencies came from John Oliver, and on his show, he told that cryptocurrency is basically everything you don't understand about money, combined with everything you don't understand about computers. And that's the best definition we can give about cryptocurrencies. I think I'm pretty lucky because you guys know how computers work, and now you have a basic understanding how this whole blockchain thing works. So now, at least we know half of the story. I don't know anything about money, how this works, but that's not the topic of our talk today. Now, let's talk about smart contracts, because we are here to talk about smart contracts and how people can hack smart contracts, right? So, deep dive into smart contracts. Not many people know that Bitcoin is also capable of doing smart contracts, but it's a bit clumsy. We will talk mostly about Ethereum, because that is the most popular platform when it comes to smart contracts. In the real physical world, whenever you are writing a contract, what you want to achieve is that you want to sign and you want to get countersign on the contract, right? That's the basic idea of a contract. And so you don't want that someone changes the content of your contract later. So what you can do is, for example, you carve this contract into a stone, and now it's in a stone in a public place. It's very hard to modify it without someone noticing it. In the blockchain world, this stone is basically the blockchain, and the reason why people cannot change these smart contracts is because there is so much energy and time spent in the blockchain itself by solving all these challenges and chaining together that it is very, very hard or even impossible to basically change the smart contracts which are already somewhere in the blockchain. What's also very cool about smart contracts that smart contract is code, and code is universal compared to natural languages. Just think about whenever there are people from different countries and they want to sign a contract and they speak different languages, it can get messy really quickly, right? But what's cool with smart contracts that you write code and the code is interpreted the same way for everyone. Just a little bit of terminology explanation we will use later. There is this terminology called the gas, and whenever a smart contract code is executed by any node in the peer-to-peer network for these math challenges, then similarly to the transaction fees, when you pay some amount of money for transact money, now because you are executing smart contract code, you have to pay a little bit of fee for this code execution, right? And this is what we call gas in Ethereum. And usually it's the same as it was with StarCraft. You don't have enough gas, right? Cool. I'm still not talking about hacking, and I'm really, really sorry about that, but I promise we are getting there. I also have to talk about Ethereum virtual machine. Most of you guys know what bytecode is, and probably you have a better definition of bytecode is, but for me, bytecode means it is not machine code, so this code cannot be directly interpreted, and you cannot directly run it on your CPU. So you need a virtual machine to execute your bytecode, and that virtual machine runs on your CPU. So there is an added layer. In the smart contract world, Solidity is the main programming language, which is the most popular one. And it has a very similar syntax compared to JavaScript. And you basically write your smart contract code in this Solidity language, then you compile it into bytecode, which will be later interpreted by the Ethereum virtual machine. And this Ethereum virtual machine runs on all the nodes which are participating in the Ethereum network. What's really cool about smart contracts is that whenever someone writes a smart contract, he or she can publish the source code for it. Everyone can check what the source code is, what it really does. And meanwhile, the Solidity source code, whenever it is compiled with the same version and with the same parameters, it will reproduce the same bytecode. And this reproducible compilation makes it easy to verify that you can check that in the Ethereum blockchain, here is a smart contract at this address. This is the bytecode that is in the blockchain. And if you have the source code to it, you can go compile it to yourself. You can cross-reference it with the bytecode you compiled, with what is in the blockchain. And now you can be sure that, yes, this was the source code, and this is now in the blockchain, and I am 100% sure that it is the same. As I mentioned, Solidity is pretty similar to JavaScript. And what's fun about JavaScript is that not just Solidity looks like JavaScript, but whenever you write the front-end application for your smart contract, we call it distributed apps or dApps. Usually there are tons of JavaScript frameworks to do that. So there are a lot of people in the blockchain world with JavaScript background. And because JavaScript was developed as a front-end technology, there is this, how could I say, strategy or saying in the front-end world that you have to move fast and break things. Because you are on the front end, if you do something bad, then you can quickly change it and it's fixed, right? Well, the issue with smart contracts is that this approach is not profitable because you write your smart contract, you deploy it in the blockchain, and you cannot change it anymore. So if you make a mistake, it's there, as long as you don't revoke your smart contract. But how do you really interact with a smart contract? It's very easy. You need a browser to do that, and that browser should support interacting with smart contracts. Either there are special browsers which already has this support, or you just go to your favorite browser extension store and you download an extension which is capable of interacting with smart contracts. The most popular extension is called MetaMask. I'm going to use this in today's demo as well. And in MetaMask, you basically create your wallet. Somehow you transfer some money to your wallet, and whenever you want to interact with a smart contract, you just open the extension, you type your password, and from now on, whenever you visit a website will be able to see that, yes, you are an Ethereum user. Even the website will be able to see your wallet address, the public address. And from now on, for example, you can register on websites, and you can link your email on this website to your public wallet address. And for example, I was signing up to CryptoKitties because back that time that was one of the most popular smart contract application in the world. And I had to confirm to this application that I really have the private key for this wallet, so I just had to sign a transaction to do that. Cool, but let's see it in action, how really a smart contract works and what the user experience is. Now, this is the CryptoKitties website, where you can buy very nice CryptoKitties, right? And I find this CryptoKitty very beautiful. I mean, who can't love him? So I'm buying this CryptoKitty with some Ethereum. I think it was something like 1,000 forint for me. And sorry for the font size, I couldn't do it better. But what's interesting here that this is the graphical user interface of MetaMask from like 6 months ago. And on the top left side, you can see that which wallet I am using to interact with the smart contract, and the smart contract's address is on the right. And I can see the amount of Ether I am spending here, which I'm spending to buy this kitty, and this money is transferred to the original owner of this CryptoKitty. And because I am both transacting Ethereum and I am interacting with the smart contract, I have to pay both the transaction fee and I have to pay some gas because I'm executing some code in a smart contract. But what was really interesting and funny to me was that in this page, I am approving that I am paying from this wallet to this wallet and this amount of money, but I have no idea what am I paying for. Am I really getting that lovely kitty, or am I paying for something else? I don't know. And I had no idea what is going on, so I checked the GitHub page of MetaMask to file an issue that I don't think this user interface is pretty good. Turned out it was not just only me who was complaining about this. So other people said that, yeah, I think it's important to see that the user should be able to see what he approves, what is inside the transaction, which smart contract function he is calling, with which parameters, and so on. But what really this tells me that Ethereum is still in a very beta stage. I mean, this user interface has been changed in the past like 2 months or so. So now it has all this data. But before that, no one really cared. So I think it's still not in a very mature phase. OK, so let's submit this transaction. And I can check on a public website what the status of this transaction is. And basically, in around 1 minute, my transaction is approved by the Ethereum blockchain. And if I go back to the CryptoKitty website and again wait some time, now I am the owner of this lovely kitty. Very cool. I was so happy that I had this kitty, right? Now the question was, what do I do with this kitty? And I had no idea. But seems like the developers of this website had some idea. For example, you can start breeding your kitties, so there will be more CryptoKitties, because that's what the world needs, even more CryptoKitties. You have no idea what to do with it. But anyway, that was my experience with CryptoKitties. Yeah, I think it's so. But why is this cool? I mean, when I did this, I was like, yeah, that's cool that I have interacted with a smart contract in my life, but what am I using for this kitty? And the explanation why this is cool is that now in the whole Ethereum blockchain, it is cryptographically tied, this CryptoKitty is cryptographically tied to my wallet. So even though the CryptoKitty website can go down, I am still the owner of this CryptoKitty. So there is no central database maintaining who has this CryptoKitty, because the blockchain is distributed between the peer-to-peer network. So if even CryptoKitty goes down, I can just set up the very similar or same front end for this application, and now I can see my CryptoKitty again alive. Cool. This is the new interface I was talking about. And on this interface, now you can see the function name of the smart contract you are interacting with, and you can also see the parameters which are used. The first part of the parameters are basically hash. The method ID you are calling is hashed and truncated. And the second part, the very, very long zeros and the last hex values are the identifier of the kitty I needed. And it was pretty amazing to see that because this identifier is so long, it means that this CryptoKitty application can have 2 on the 2 power 256 CryptoKitties, which is, I think, a lot. But who knows? Maybe someone wants to buy all of them. Okay, but now let's talk about hacking, right? What's cool about smart contracts is it is code. And you are Hacktivity participants, you know code can be hacked, right? So that's good news for us hackers. I'm going to show you like 4 or 5 different incidents which happened in the past 2-3 years. And the first one is, I think, the most famous ones. I want to check it. How many of you guys heard about this hacking story? Okay, that's cool. That's cool. So DAO stands for Decentralized Autonomous Organization, and it was basically a special smart contract which can work like a very basic company. This means that people who are participating in the smart contract can vote on things, they can have share in things, and you can do very, very basic stuff that you can do in a company. And when they started, they crowdfunded a hell of a lot of money, like 130 million US dollars at the very beginning, which is a lot of money. And yeah, this article is from 2016 May, and on June there was a blog post that someone is calling out that yeah, there might be issues with this kind of smart contracts because it is possible that an attacker can steal money from these smart contracts. Luckily, some days later, these smart contract developers created a new blog post where they explained the situation, and they told that they have analyzed their smart contract and this hack, and basically everyone can calm down. There is no issue here. This smart contract is not exploitable. This was June 12th. 6 days later, an attacker transfers 250 million US dollars worth of Ethereum from this smart contract. That is 1,250 Lamborghinis you can buy from this money. I mean, there is like 40 Lamborghini on this slide. Can you imagine 1,250 Lamborghinis? That's a lot of money. And the main issue was this vulnerability called reentrancy at the split DAO function. But what is this reentrancy vulnerability? So let's imagine that you go to your bank, where you have a bank account with, I don't know, 500 US dollars. You ask your bank teller that, hey, can you check me how much money I have? Sure, you have 500 US dollars. Okay, I want all of them. And the bank teller starts to count the money to you. But before he goes back to his machine and finishes this transaction and zeroes your account balance, you can interrupt this bank teller and, hey, before finishing this transaction, can you please give me 500 US dollars? And smart contracts are not smart. I mean, these are just code, so they do whatever it was coded to them. And because this smart contract was not that smart, the attacker was able to interrupt the code at this stage, and the account balance was not updated. So basically, the dumb bank teller looks at your balance. Yeah, you still have $500, so I'm giving you another $500. And you can do this attack as long as there is money in this branch, right? And then you just run. And this is what happened in this code, actually. The code I'm showing to you is not the same, which was in the smart contract, but the issue is very similar. So there was this withdraw balance function, and it checked how much money the user had in the smart contract. And then it had this pretty complicated function call, and it's basically a message to the user that, okay, now you are receiving some ethers. You are basically receiving the ethers you stored in this smart contract. But what is really bad with this function call is that the attacker can control the code which gets executed at this stage. So if our attacker is halting this transaction at this stage and starts a new withdrawal balance, the balance of the user is still not updated in the smart contract, so he can keep calling it and calling it and calling it as many times as there is money in the smart contract. And the issue was here that the user balance was updated only at the end of the transaction. And you shouldn't do that. This is bad design. And yeah, this is basically what happened. Everyone was pretty hyped about Ethereum, and they spent all of their hard-earned money on this DAO smart contract, and yeah, it was just stolen. What was the solution to solve this issue? As we already discussed that everything in the blockchain world is irreversible and immutable. Well, there are ways you can hack it. For example, if all the nodes, I mean the majority of the nodes who are participating in the Ethereum blockchain mining, they are accepting the fact that this was not okay, then someone can basically create a patched version of the Ethereum client, and this patched version can basically revoke this hack and make it look like it never happened, right? Which is kind of shady, because that's the reason why you are doing smart contracts, that you don't do this kind of thing. But because even though the majority accepts that the hack never happened, there can be still mining nodes which don't accept the revocation of what really happened here. So basically this was a so-called hard fork. And from now on, there are two different chains in the Ethereum world. One is called Ethereum Classic. In Ethereum Classic, the hack happened, and actually the attacker was able to get away with 67 million US dollars, which is 335 Lambos. And the reason why he only had this amount of money was that now, because there are two different chains with basically two different cryptocurrencies, the market is different for these two. So still today, Ethereum Classic is worth less than the Ethereum, what we mostly use and know nowadays. But still, it was worth for some people. So the guy was able to make a hell of a lot of money from this hack. And that what I really, really loved about this guy, that he was an awesome troll, because he posted a blog post. And in this blog post, what he wrote is amazing, is that because smart contract is code, he didn't hack the code because the code really allowed him to do this. So he basically thanked the developers of the smart contract, how generous they were that they gave all their money to him. I mean, it's amazing. I love this guy. Anyway, let's talk about some different topics, and let's talk about multi-signature wallets. Multi-signature wallets are a bit special because in this case you can have basically multiple people in your wallet, and multiple people have to sign, for example, a transaction that if you want to move Ethereum out of your smart contract, you need multiple people to approve this, which is kind of cool, right? How many of you guys know Captain Planet? Okay, good generation. So have you guys know that Captain Planet was the first multi-factor authentication? You never really thought about this, right? So in our next hack, which happened in 2017, it's called the Shared Vulnerable Library and Reinit attack. In this case, only 155 worth of Lambos were stolen, which is still a lot, I would say, still a lot. And turns out that a lot more money was in danger, but there were some good guys, and the good guys realized that a hack is happening in the blockchain world, and the hacker is exploiting a lot of vulnerable smart contracts. So what the good guys did, that they exploited these vulnerable smart contracts the same way as the bad guy did, but the good guys collected all the money for themselves, and they waited for the smart contracts to be replaced with new fixed versions, and at the end of the day, the good guys gave back all the ethers to the original smart contract owners. Now, there are some shared libraries in the blockchain world because smart contract is code, so why not sharing your smart contract code with anyone, right? With this architecture, you can save some gas, but also what's pretty cool from a hacker point of view, if people are using a vulnerable shared library, it means everyone is vulnerable. So you are not just sharing your code, you are sharing your vulnerabilities. And in this case, there was this company called Parity, and their multi-signature wallets were basically hackable. Now, there are two codes I'm talking here. One is the template code for the multi-signature wallet, and this template smart contract had this function. This function payable, it's a special syntax for code which will be executed whenever someone called a function in our smart contract which doesn't exist. So it's like a fallback function, right? And in this code, there was this code path. If there is no ether sent to this smart contract, but some data was sent to our smart contract, then this wallet library delegate call function was called with the parameters sent to our smart contract. And the wallet library is the vulnerable shared library. And delegate call means that we will call a function in this vulnerable library, but everything will run in the context of our smart contract, right? So what happens if our vulnerable shared library has an init wallet function? Right? And in the initialization stage, you can define who are the owners of the smart contract. And what's interesting here is that basically the hacker had to call the init wallet function in all the smart contracts he wanted to hack. Init wallet was not implemented in the template, so the template smart contract was calling the vulnerable shared library, and in the vulnerable shared library there was this init wallet, and it was running in the context of the original template smart contract. So basically, the hacker was able to initialize all these smart contracts to his, so that now he is the only owner of the smart contract, and from now on he was able to steal all the money which was stored in the smart contract. So you can say, yeah, Ethereum is in a beta stage and people have no idea how to code, but as it turns out, this multi-signature wallet code library was published by a guy called Gavin Wood, who is the main developer of the Solidity language. And which means even the guys who created Solidity don't know how to securely code smart contracts. That's bad. Now, what do you, if you have an issue, you try to fix it, right? So Parity admitted that there was an issue, and they created a new shared library and a new multi-signature wallet smart contract template. If you are a developer, if you are fixing a bug, what do you do meanwhile fixing a bug? You create a new bug, right? And this bug was spotted by a guy, and here is the GitHub comment about that. There was this issue that this new shared library was implemented in the blockchain without proper initialization. And the developers admitted that, yeah, we know about this, we will take care about this, that's okay, it's not a huge issue. Now, what happened next is $300 million worth of Ethereum was lost, which is, again, 1,500 Lambos. And this is not stolen, it is lost forever. And what happened here is that there is this guy called DevOps199, and he accidentally called the init wallet function on the single shared library deployed in the blockchain. And because it was not initialized before, he became the owner of the contract. And if you are the owner of the contract, you have special rights in the contract. And some people don't know whether it was really accidentally or not. We will never know. But after that, this same guy accidentally called the kill method on this shared library. And by destroying the shared library, it means all the other smart contracts which were depending on this shared library are now not functionable, are not accessible anymore, and all the Ether which was stored in the smart contract is gone forever. Again, people were talking about, yeah, we can fix this with code and some forking, and yeah, we can get back all the money, but at the end of the day, the community voted with no, we don't do that, this money is lost forever. All right, let's talk about a little bit about integer underflow. So I think the best explanation how you can explain integer overflow to your kids is that let's say that there is a bus, and in your code you want to store the number of people on the bus on an unsigned integer on 8 bytes. So let's say that there are 3 people on the bus. And if 4 of them took off the bus, how many people are still on the bus, right? The correct answer is 255 people. That's just how computers work, yeah? And the same with overflow. Like if there is a bus which is already full of people, and one guy hops onto the bus, you got an empty bus. That's how life works, that's how computers work, right? Now there was this awesome smart contract. Oh, I love this. What's really cool about smart contracts that you deploy it in the blockchain and they are there forever. So if you deploy a smart contract which is a scam, the scam lives in the blockchain forever, right? And it's a little bit of complicated how this scam works. I really don't want to go into detail in this, but if you want to have fun, I recommend you to check these kind of proof of weak hands smart contracts. They have an awesome story. Long story short, one of these smart contracts, it turned out they were coded by guys from 4chan, and they were not the best Solidity developers in the world. And there was an unsigned integer underflow issue in their smart contract. So basically, the $2 million stored in the smart contract was lost. Moral of the story, there are shared libraries in the Ethereum blockchain which you can use, and they already implemented safe math in it, so you don't have these issues like integer underflow and overflow, so you should use safe math. Now, what is the conclusion? Blockchain, Ethereum, and smart contracts are here to hack. And I believe still today, writing secure smart contracts is hard. The Ethereum is still in beta, and hacking smart contracts is possible, fun, maybe illegal. I'm no lawyer, so I don't know about that. Probably if you create your own smart contract and you hack that, it's probably not illegal. Again, I don't know, but there are also test blockchains, so probably it is better to test your hacking skill in the test blockchain. And I think one of the main conclusions here is that the smart code developers need our help, and we have to teach them how they can write better and more secure smart contracts. And it is important that we start a discussion and we don't do this. This is a totally separate world and we are not interested in them thing. If you want to learn Solidity, I think one of the best tutorials is this cryptozombies.io, which is a very awesome and interactive tutorial where you can learn the bits and bots of Solidity. And there are also awesome CTF hacking games in the test Ethereum blockchain. One of the best ones is called the Ethernaut, and these are very, very cool challenges. When I started to learn about Ethereum and Solidity, at one point in time, I had the feeling, okay, I get this, and I understand how it works and how these smart contracts can be hacked. But when you start hacking a real smart contract, you quickly realize you know nothing. I mean, it's totally not how you thought it works, but it can really give you a hands-on experience how you can hack smart contracts. There are some references, and that's all I wanted to share with you guys. Thank you for your attention.